All right, let's take a look at the practice test here. The first question was just solve the equation x minus 2 times x plus 1 equals 0. It's already factored, and it's already equal to 0. Let's see if we get the right pen. So when we're doing this, we're just going to take the two factored pieces, the x minus 2, set it equal to 0, and then take the x plus 1, set it equal to 0, and then just solve both of these. So the first one we're going to set equal to 0 and solve by simply adding 2 to both sides. We get the answer of x equals positive 2. The other one we're going to subtract 1 from both sides, and we get the answer of negative 1. So we would say that x is equal to 2 and negative 1. In number 2, find the coordinates of the vertex, the x-intercepts, and the y-intercept of the related functions, then graph it. Y-intercept, that's easy because that's the c value. So we can put that as 0, negative 6. Factored form, we're going to draw our x. We're going to put our c value at the top, our b value at the bottom, which would be a 1 because there would be a 1x here. And then we need our two numbers that multiply to negative 6 that add to positive 1. That would be a 3 and a 2, with the 2 being negative. So we would put this in factored form as x plus 3 times x minus 2, and that would equal y, which, if we do the work that we just did up above to find the factored or to find the solutions from factored form, we would take our x plus 3, set it equal to 0, which would give us an answer of x equals negative 3. And we would do the same thing with x minus 2. We'd set that equal to 0, and we'd get our other solution at 2. So if we're graphing this thing, we've got our solutions here. We've got a y-intercept there. Now our vertex, there's two pieces to it. The first piece is to do negative b over 2 times a, which would be negative 1 over 2 times 1, which would be negative 1 over 2. That's our x value, which would also be our axis of symmetry. And then the second piece of that is to take y equals, now we know what our x value is, it's going to be negative 1/2. We're just subbing this back into the equation. So negative 1/2 squared plus negative 1/2, because that's x, and then minus 6. So if we evaluate that, negative 1/2 squared is 1/4 positive, minus 1/2 minus 6. 1/4 minus 1/2 is negative 1/4. And then that minus 6 would be negative 6 and 1/4. All right, number 3, simplify the square root. Again, when we're doing these, our goal is to figure out what two numbers can I multiply 52 to, with one of those numbers being a number that has a square root. So I'm thinking like, hey, does 36 go into 52? And it doesn't. Does 25 go into 52? And it doesn't. Does 16 go into 52? And it doesn't. Does 9 go into 52? And it doesn't. Does 4 go into 52? It does. And it goes in 13 times. So those become our two numbers. We're going to go square root of 4 times the square root of 13. And we know that the square root of 4 is 2. And the square root of 13 would stay square root of 13. And we know we're done there because 13 is prime, so I can't simplify that. I can't break that into any other parts. So anytime that's the case, you know you're done. So we would just write that like this. 47, again, if we kind of do the same process that we did over here, 36 doesn't go into 47, 25 doesn't go in, 16 doesn't go in, 9 doesn't go in, 4 doesn't go in. So we don't have anything that goes in to 47, so we just say it's already simplified. All right, when we do the part C, I'm going to break this into two separate parts. I'm going to do the square root of 8, and then I'm going to do the square root of x to the 9th. So square root of 8 is a pretty common one that breaks into the square root of 4 times the square root of 2, and the square root of 4 is 2, and the square root of 2 stays where it is. Now, with square root of x to the 9th, again, that would be the same thing as x, 1, 2, 3, 4, 5, 6, 7, 8, one more. Again, what we're looking for here is pairs. So I've got, oops, that's too thick. So let's change, can I change colors? So I've got a pair of x's, I've got another pair of x's, I've got another pair of x's, and I've got another pair of x's. So what I end up with is 4 pairs and 1 left over. And what we do is how many pairs I have goes on the outside, so x to the 4th, and then because I have 1 left over, that stays behind. So when we put this together, I've got a 2 and an x to the 4th on the outside, and on the inside, I have the 2, and I've got an x. All right, so we use that idea here to answer these questions. First one is x squared equals 25, or what number times itself is 25? Again, if we need to, what we're doing here is taking the square root of both sides. And when we do that, the square root of a square is just the thing itself. And on this side, we're going to go plus or minus the square root of 25. And since we have a square root of 25, which is 5, we'd go plus or minus 5, and we'd leave it at that. In letter B, we have to get the x squared by itself, so we're going to subtract 19 first. So we've got x squared equals -1, and that's where we'll stop, because if we have x squared equals a negative number, it doesn't matter what that number is, we can't solve it. So we just write no solution or no real number and call it good there. In letter C, we can start by getting those two pieces combined by adding. We want to get x squared by itself, so we're going to divide by 5. So we've got x squared equals 20. Just like we did in letter A, now we'll take the square root here, the square root there. So we have x equals plus or minus the square root of 20. Square root of 20 is one that we often will simplify into plus or minus square root of 4, square root of 5. And since we know square root of 4 is 2, this will become x plus or minus 2 square root of 5, and call it good. What value of c would create the perfect square trinomial? We take our value, our b value, divide it by 2, and square it. So 14 divided by 2 is 7, and 7 squared equals 49. So if we needed to create a perfect square trinomial, we would put a 49 there, which is what we'll do in 6. We're going to solve this by completing the square. First thing we need to do is figure out what number goes here. That's the value that would complete the square, the c value. So we'll do 6 divided by 2 and square it, which is 3 squared, which is 9. So that value goes in there, which gives us x squared plus 6x plus 9 equals 17. What we're able to do with this perfect square trinomial on the left side is turn this into x plus 3 quantity squared. And again, the 3 comes from the fact that it's 6, which is our b value, divided by 2. So we've got x plus 3 squared equals 17. Again, we're going to square root both sides of this, which gives us x plus 3 equals plus or minus the square root of 17. Now, if we could square root 17, we would. 17's prime, so we're going to have to leave that. But what I can do is subtract my 3 from both sides. And I will put that in front of my plus or minus. And we'll write our answer like that. And then, just to be complete, we'll branch that off. Again, just to be clear, this would be an okay answer. But again, if we could square root 17, we would then do our two pieces here where I do negative 3 plus the square root of 17 and negative 3 minus the square root of 17. And I'd get those two different answers. All right, number 7, a company shows profits when their business with the function negative 0.02x squared plus 0.8x minus 3.5. X is the number of units they sell, and P is the profit. So it says how many units are sold by the company to earn to earn the maximum profit. Again, that's going to be the x value of our vertex. So we really simply can just do negative b over 2a here. The negative b would be negative 0.8, and that's on top of 2 times negative 0.02, which is negative 0.8 over negative 0.04, which is negative on top of a negative is positive, so 0.8 over 0.04, which equals 20. So 20 units, again, that's the x value of the vertex. We don't need to find the y value because it doesn't ask us what the profit actually is. So in B, it says just between which numbers of the units does the company show a profit. So again, if we think of our graph here, I want to be on top of the x-axis. So again, we don't know what our graph looks like right now, but we know it's a parabola. So again, we're looking for this chunk here, which means, again, I just need to figure out where does it cross the x-axis, which we could use the quadratic formula here, and we could go up here and say, well, here's my a value, here's my b value, here's my c value, which would be one way, but because of the decimals in there, I'm not a fan of that. So I think it's easier if we just look at, in this case, I would just look at decimals and say, here's my equation. Where does it cross the x-axis? Well, we see one time that it crosses the x-axis at 5, and the other time it crosses the x-axis at 35. We would also see that in a table. If we looked at the table of values, and again, we were looking at x and y, we would see 5, 0, and we would see 35 with a 0. But what we just saw there was x equals 5, y equals 0, x equals 35, y equals 0. So between which two numbers, again, we could write this a couple different ways. We could just really just write that between 5 and 35. We could also write that as a compound inequality. X needs to be less than 35, while at the same time greater than 5. And we want those just to be less than or greater than signs. We don't want equal to because we don't actually want it to be 5, nor do we want it to be 35. Question 8 says use the completing the square idea to find the vertex. So first thing I'm going to do is go plus 21 to give us 21 equals x squared plus 10x plus that c value. So we're going to go 10 over 2 squared, which is 5 squared, which is 25. So that's our c value. And we're going to add it to both sides. So we get 46 equals x squared plus 10x plus 25. What that allows us to do then is on the right side, turn that into a perfect square trinomial by going x plus 5 squared. Again, notice it's x plus 5 because half of positive 10 is positive 5. We still have this 46 over here, but what we're going to do with that is subtract 46, and that gives us a vertex form of y equals x plus 5 squared minus 46, which makes our vertex simply negative 5. Just remember that's the opposite of that value. And then negative 46, because the y value is just what's sitting right there. Use the quadratic formula to solve this. So we're going to have an a value of 1, a b value of 9, and a c value of 20. Again, standard form, which it is, equal to 0, which it is. So that allows us to start. So we're going to go negative or opposite of b over 2a. Our b value is 9. Our a value is 1. So that first part becomes negative 9 over 2. And yeah, that's negative 4.5. But let's leave it in a fraction. Let's see what happens in part 2, which will be b squared minus 4ac all over 2a. So my b value was 9, so 9 squared. Again, remember that's going to be a square number, so it's always positive. Minus 4 times a times c, all over 2 times a. So again, part 1, we're going to square that 9, which is 81. Again, that will always be positive. Part 2 then is to multiply these three numbers together. So I'm going to take negative 4 times 1 times 20, which is negative 80. So I'll just write negative 80. And that's on top of 2 times 1, or 2. 81 minus 80 is 1. So we've got the square root of 1 over 2. Now we can square root 1. We don't think of that one, but we can square root 1, and it's just 1. So that's 1 over 2. So now we put our two parts together. We're going to do our first part plus or minus our second part. Now, again, these are always going to have the same denominator, so I can put this together and go negative 9 plus or minus 1 over 2. And then we can branch this off and do our two different answers. Negative 9 plus 1 over 2 and negative 9 minus 1 over 2. Negative 9 plus 1 is negative 8 over 2 is negative 4. Negative 9 minus 1 is negative 10 over 2, which is negative 5. And those are our two solutions. Now, question 10 says use the discriminant to find the number of solutions. Going back to this question, this part right here is the discriminant. So it's just simply that b squared minus 4ac. So our a value is 1, our b value is 8, our c value is negative 10. So we're going to do b squared, or 8 squared, minus 4 times a times c, which is negative 10. 8 squared is 64. Again, this part gets multiplied together. Negative 4 times 1 times negative 10 is going to be positive 40. 64 plus 40 is 104. So the one thing that matters there is that 104 is greater than 1, which means there's two solutions. If it were 0, then it's one solution. If it were negative, then there's no solution. But because it's positive, it's greater than 1, or I guess it's greater than 0. Because 104 is greater than 0, it's a positive number, we're going to have two solutions. And then we could use the quadratic formula to figure out what those solutions are. Last one is 11. It says solve the system using any method. So we could graph this, right? We've got our linear on top and our quadratic on the bottom. I'm going to use an algebraic method. So I'm going to go y equals x squared minus 2 and y equals negative x plus 4. And I am going to use elimination, which means I'm going to subtract these two. So y minus y becomes 0. There's the elimination. Now we're just going to keep going step by step. X squared minus nothing is still x squared. This one was a little bit tricky because we do have a 0 here. So we've got 0 minus a negative x, which is really 0 plus x. So that ends up being positive x. And then negative 2 minus 4 is negative 6. So what we have is x squared plus x equals 6 equals 0. We now need to solve that for x. So the first thing I'm going to try to do is factor this, because factoring is the easiest way to solve, in my opinion. So I'm going to put negative 6 on top and 1 on the bottom. Two numbers that multiply to negative 6 that add to 1. Again, 3 and 2, with the 2 being negative, because 3 plus negative 2 is positive 1. So in factored form, this is x minus or x plus 3, x minus 2. So just like we've done in previous problems up above, I'm going to get x values of negative 3 because negative 3 plus 3 is 0, and positive 2 because 2 minus 2 is 0. So those are our x values. Now what we need to do with those x values is find the y values. So I'm going to make x be negative 3, and I'm going to sub that back into one of the two equations. So again, I could do that equation or that equation. And honestly, with the negative x there, I don't mind just using the x squared. So we're going to do y equals x squared minus 2. And I'm going to use that with both of these. Let's use black. And again, I'm going to take the negative 3 and sub that into this equation. Negative 3 squared is 9. 9 minus 2 is 7. So y equals 7, giving us a point of negative 3 comma 7 for one of them. We'll do the same thing with the 2. So 2 squared minus 2 is 4 minus 2, which is 2. So y equals 2 when x equals 2. So there would be the two spots where they would cross. So if we graphed them, we would see 2 comma 2, negative 3, comma 7 as our spots where those two things cross. Again, negative x plus 4 would look like this. X squared minus 2 would look something like that. All right, that does it.